Okay, conservation of momentum. We dealt with the conservation of momentum in one lecture. Your parents were here. And we only dealt exclusively with completely inelastic collisions. Whenever we have a system of objects with zero net external force, the momentum must be conserved. They can collide, they can cause fireworks, they can explode, they can break up in pieces, but momentum will be conserved in the absence of any net external force. It's a very non-intuitive concept. Kinetic energy can be destroyed, but momentum cannot be destroyed in the absence of a net external force on the system as a whole. We have an object M1 here, speed V1, object M2, speed V2. Let's make it very simple. M1 is 1 kilogram, V1 is 3 meters per second, M2 is 2 kilograms, and V2 equals, I make this 5 meters per second, and I make this 3 meters per second. Momentum is conserved, so I can write down that M1 times V1 plus M2 times V2 must be M1 plus M2. It is a completely inelastic collision times V prime. They come together, they stick together, the total mass is going to be M1 plus M2, and they're going to fly either in this direction or in this direction, but whatever it is, I call it V prime. It's after the collision. You may say, hey, you forgot your arrows here because this is a vector equation. Yeah, I purposely forgot them because this is a one-dimensional case. You can always leave the arrows off because the signs take care of it. And you, of course, have to be generous. Namely, you have to put the minus signs in when needed. MV is 1 times 5, that is plus 5. M2 V2 is going to be negative because I must now observe this as a minus 3, so I get minus 6. So the momentum before and after the collision must be minus 1, and that must be equal to 3 times V prime. And V prime is therefore minus 1/3 meters per second. And so these objects will stick, and after the collision, they will move with a speed of 1/3 of a meter per second. Kinetic energy was almost exclusively lost. There was almost nothing left, remember? Clearly, that's because of friction, not external friction. There is no external friction, because if there were any external friction, momentum would not be conserved. Think of them as the two car rags. They go into each other. Fireworks, man, you hear them scratch, metal over metal. A lot of heat is produced. Kinetic energy is removed. But momentum is conserved, because those frictional forces are all internal. And that's fine. So that is why it is such a very non-intuitive concept.